Hello friends, welcome to my channel Academic Made Easy PC. Question number 4. Show that the modulus function f from R to R, that is real numbers, given by f of x is equal to mod x is neither 1 to 1 nor onto, where mod x is x if x is positive or 0 and mod x is minus x if x is negative. So now I have written the given f from R to R and f of x is equal to mod x to prove f is neither 1 to 1 nor onto. Now proof. First 1 to 1. So in this mod function, we have to take three cases. Why? Because modulus of any number will give the number in positive. Even the negative numbers will be converted into positive number when we remove the modulus, isn't it? So only we will be taking three cases. Case 1 will be let x1 comma x2 be two positive real numbers. Okay, so when we check f of x1 is equal to f of x2, we will get x1 mod is equal to x2 mod. Okay, it is already given in the question that mod x is x if x is positive or 0. We have already said it is positive. Then we will get x1 is equal to x2. Okay, so x1 is x1 itself, mod of x2 is mod x2. Now, we cannot conclude with this because already I said no, we have to take three cases. So, case 2 will be let x1 comma x2 be two negative real numbers. That is, they belong to real numbers where x1 and x2 are negative. So the same f of x1 is equal to f of x2. So mod of x1 is equal to mod of x2. In the question, it is clearly given that mod of x is minus x if x is negative. No. So minus x1 is equal to minus x2. When we cancel these two, we will get x1 is equal to x2. These two conditions are also satisfied. If both are negative, the condition is satisfied. What if one x is positive and the other x is negative? Let's check. Case 3. Let x1 comma x2 belong to R, where x1 is positive and x2 is negative. Okay, so f of x1 is equal to f of x2. So mod of x1 is equal to mod of x2. So mod of positive is x only, mod of negative is minus x, so minus x2. Therefore, this condition is not satisfied. So I will say that f is not 1 to 1 onto. For every x belonging to R, there exists y belonging to R. Okay, so f of x is equal to y. F of x mod x is equal to y, isn't it? So, minus 1 belong to R in the codomain, isn't it? In the codomain. But there exists no element in the domain whose modulus value is negative. So we won't get the answer, that is range minus 1. So real numbers consist both negative as well as positive, but modulus function will always give us what? Positive. But here there is no negative, so it is not onto. Therefore, f is not onto. Question 5. Show that the synonym function f from R to R real numbers given by f of x is equal to 1 if x is greater than 0, 0 if x is equal to 1, minus 1 if x is less than 0 is neither 1 to 1 nor onto. Now I have written the given part and proof part. Proof, what we have to prove is that f is neither 1 to 1 nor onto. Given that f of x is equal to, we'll write the same thing. If x is greater than 0, it means 1, 2, 3, etc. If it is greater itself, everything is mapped to 1. So automatically this becomes many to one function. Therefore, it is not 1 to 1 function. Therefore, f of x is not 1 to 1. So in range, what all is there, we'll write range. It is given already. This is range. Okay. Range is already given. We'll write 0, 1, minus 1. Okay, this is the range given. So real numbers is in codomain, but range consists only 0, 1 and minus 1. So for onto, the condition should be range is equal to codomain, but here range is only 0, 1, minus 1. So automatically we'll come to know that f is not onto. Question 6. Let A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7 and let F is equal to 1, 4, 2, 5, 3, 6 be a function from A to B. Show that F is 1 to 1. Proof, we have to just show f is 1 to 1. So here we need not to do onto. So for 1 to 1, x1 should be equal to x2, isn't it? So 1 to 4, 2 to 5, 3 to 6. So every one element is mapped to one element only. Now since the elements in the domain have distinct range or image, it is proved that f is 1 to 1. That's all. Question 7. In each of the following cases, state whether the function is 1 to 1, onto or bijective. Justify your answer. First subdivision. Function from R to R real numbers defined by f of x is equal to 3 minus 4x. Solution. First 1 to 1. Let x1, x2 belong to R. Therefore, f of x1 is equal to f of x2. So, what is f of x3 minus 4x? So, here 4x1 and here 3 minus 4x2. So, these two will get cancelled. So, minus 4x1 is equals to minus 4x2. So, when you cancel this also and 4 and 4 also gets cancelled. So, x1 is equal to x2. Therefore, f is 1 to 1. Next for onto. For every x belonging to R, there exists y belonging to R. So f of x is equal to y. Then 3 minus 4x is equal to y. So we have to get x in terms of y, no? So minus 4x is equal to y minus 3. X is equal to y minus 3 by minus 4. X is equal to 3 minus y by 4. I just took the negative sign inside here. So I got the x in terms of y. So now f of 3 minus y by 4, that is the x value I am writing here. So 3 minus 4x. So we will have 3 minus 4 into, this is 4. 3 minus y by 4. So 4 and 4 gets cancelled. So we'll have 3 minus 3 plus y, which is equal to y. So f of x is equal to y. Therefore f is onto. Therefore since f is 1 to 1 as well as onto, this is bijective function. Second subdivision. Function from R to R real numbers defined by f of x is equal to 1 plus x square. Solution. First one is 1 to 1. Let x1 comma x2 belong to R. So f of x1 is equal to f of x2. So 1 plus x square is equal to 1 plus x square. So we can cancel 1 and 1. x1 square, x2 square. Okay. x1 square is equal to x2 square. x1 is equal to x2. If you remember the previous sums, this one you yourself will be able to guess what will happen next. So now we are going to take an example. Since it is a square, minus 1 square is equal to 1. Okay, 1 square also is equal to 1. So but minus 1 is not equal to 1, no? So we cannot have this x1 equal to x2. F is not 1 to 1. Next, on to. For every x belonging to R, there exists y belonging to R. Okay, so f of x is equal to y. So 1 plus x square is equal to y. So x square is equal to y minus 1. X is equal to root of y minus 1. Okay. So when we take, for example, when we take f of x is equal to minus 1, then we will get the answer as 2, isn't it? So everything is positive. Whatever number we take, we will get it in positive. So the range will be positive numbers. Positive numbers. So in codomain, negative numbers as well as positive numbers are there. But in range, only positive numbers are there. So we will say that it is not onto also. It is not onto. Question 8. Let A and B be two sets. Show that function from A cross B to B cross A such that f A comma B is equal to B comma A is bijective function. So to prove f is bijective function, proof. First one is 1 to 1. I have to check whether it is 1 to 1. So let A1 comma B1 and A2 comma B2 belong to A cross B. So f of A1 comma B1 is equal to f of A2 comma B2. So I will have B1 comma A1, because that is the function given, is equal to B2 comma A2 if B1 is equal to B2 and A1 is equal to A2. I'm saying if these two B1 and B2 are equal and A1 and A2 are equal, then it will be 1 to 1. So A1 comma B1 is equal to A2 comma B2, that is F of no. So that's what I'm writing. Okay, so therefore F is 1 to 1. I'm showing that if this is equal, then it will be 1 to 1. Okay. Next, on to. For every x belonging to A cross B, there exists y belonging to B cross A such that y is equal to B comma A. Okay, y is equal to B comma A, I'm saying, and y belongs to B cross A because it is in the codomain. So for every domain, there is a codomain. So every elements will be mapped. So I'm saying that codomain and range will be equal. So therefore, there exists x belonging to A cross B such that x is equal to A comma B. Therefore, F is onto. Since F is 1 to 1 as well as onto, I'm saying F is bijective. Hence proved. Okay. Question 9. Function from n to n be defined by f of n. This is the given function. State whether the function f is bijective. Justify your answer. Case 1. Let x1 comma x2 belong to R where x1 is odd, x2 is also odd. Okay, so I will have f of x1 is equal to f of x2, and in place of n we will be replacing by x. Okay, that's the only difference. So x1 plus 1 by 2 is equal to, x1, x2 plus 1 by 2. So 2 and 2 gets cancelled. So x1 plus 1 is equal to x2 plus 1. 1 gets cancelled. So x1 is equal to x2 when it is odd. Okay. So for even now. Case 2. Let x1 comma x2 belong to R and both are also even. So f of x1 is equal to f of x2. So it will be x1 by 2 is equal to x2 by 2. So x1 is equal to x2. Let x1 comma x2 belong to R and x1 is odd, x2 is even. Okay, so now f of x1 is equal to f of x2. Then x1 is odd, no? So x1 plus 1 by 2 is equal to x2 by 2. 2 and 2 will get cancelled. x1 plus 1 is equal to x2. x1 minus x2 is equal to minus 1, or x2 minus x1 is equal to 1. So here it is satisfied, here it is satisfied, but here it is not satisfied. The condition is not satisfied. So therefore, f is not 1 to 1. Now for onto. For every x belonging to, there exists y belonging to n. Okay, so now for odd, let's take f of x is equal to y. Okay, so f of x is x plus 1 by 2. I wrote f of x, so I'm replacing n by x. So x plus 1 by 2 is equal to y. X plus 1 is equal to 2y. X is equal to 2y minus 1, and f of 2y minus 1, I got it in terms of y, no, that I'm substituting here. So x plus 1 by 2, so f of x is equal to 2y minus 1. I'm substituting for x value. So f of x is equal to 2y by y, sorry, 2. F of x is equal to y. Now it is proved for odd. Next for even. F of x is equal to y. X by 2 is equal to y. X is equal to 2y. And f of 2y is equal to x by 2. F of x is equal to 2y by 2. F of x is equal to y. Therefore, f is onto. Okay, so if we take separately, we will get one onto function, but it is not one to one. Therefore, it is not a bijective function. Question number 10. Let A is equal to R minus 3 and B is equal to R minus 1. Consider the function from A to B defined by f of x is equal to x minus 2 by x minus 3 is 1 to 1 and onto. Justify your answer. So now we have to check whether this function is 1 to 1 or onto. Okay, so as usual, 1 to 1. So let x1 comma x2 belong to R. Okay, so f of x1 is equal to f of x2. So therefore, x1 minus 2 by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. So therefore, x1 minus 2 into x2 minus 3 is equal to x1 minus 3 into x2 minus 2. I've just cross multiplied. Okay, so I will have x1 x2 minus 3 x1 minus 2 x2 plus 6 is equal to x1 x2 minus 2 x1 minus 3 x2 plus 6. So now what all I have common, I will cancel 6 and 6 and x1 x2 x1 x2. Okay, so now I will change the sign. So 3x1 plus 2x2 is equal to 2x1 plus 3x2. In the next step, I'm going to group the similar variables. It means 3x1 minus 2x1 is equal to 3x2 minus 2x2. It means that x1 is equal to x2. So therefore, f is 1 to 1. Now let's see for onto. Okay, for every x belonging to n, there exists R, there exists y belonging to R. Okay, so f of x is equal to y. So x minus 2 by x minus 3 is equal to y. So x minus 2 is equal to y minus 3y. So x is equal to xy minus 3y plus 2. So x minus xy, grouping of x, we will get x minus xy is equal to 2 minus 3y. Okay, so when we take x common, 1 minus y is equal to 2 minus 3y. Therefore, x is equal to 2 minus 3y by 1 minus y. Okay, so now f of 2 minus 3y by 1 minus y, if we do, so now we will get x minus 2 by x minus 3. Okay, so now we have to substitute the value of x over there. So 2 minus 3y by 1 minus y minus 2 divided by 2 minus 3y by 1 minus y minus 3. Okay, so now cross multiplying all those, 2 minus 3y minus 1 plus 2y divided by 1 minus y, the whole thing divided by 2 minus 3y minus 3 plus 3y divided by 1 minus y. So the denominator of both the things are same, so I'm cancelling those two. And here I have, sorry, here it is 2 minus 2, so plus 2 and minus 2 gets cancelled, and minus 3y and plus 3y gets cancelled, and here minus 3y plus 2y is minus y divided by minus 3 plus 2 is minus 1. So I will get f of x is equal to y. Therefore, f is on 2.
Thanks for watching my video. Like, comment, share and subscribe.